Good morning, ladies and gentlemen. At least it's morning when I'm making this video. Today we are going to do a pretty easy section, which is graphing absolute value inequalities. This is easy because we've just graphed absolute value and we've just graphed inequalities, so all we're doing today is putting them together. It's going to be a quick one for you. I apologize for any noises that my cat makes. I am powerless to stop it. So we'll start here with the general form of absolute value inequalities, which is something that we saw the other day. That's going to be y equals, oh look, here's the kitten, you can see her, y equals, and then we've got a absolute value of x minus h plus k. So we remember that hk was the vertex form of absolute value, which means that we have our h value, and notice that that is a subtraction sign, and we've got our k value, which is added on, where then hk is the vertex of the equation. So, a couple of other things here. We want to, because we're graphing inequalities today, we're going to think about shading, and we're going to think about the idea of dotted and solid lines. So, again, there's a cat here. You can see her. Mac is being wonderful during this break. So we're going to use a dotted line if we have an inequality that is a less than or a greater than with no equal sign, same as always. We're going to use a solid line for a less than or equal to, or a greater than or equal to. So either of these is going to be the dotted or solid rules. We are going to shade these because, again, they are inequalities. So if we've got a greater than or equal to, we're going to shade above. If we have a less than or equal to, we're going to shade below. So coming down here, we've got just a few examples, just the same kind of things as you've seen. Cat just stepped on my paper, that's why it's wet. So we've got y is less than absolute value of x plus 2. So first of all, we think about our vertex. Our vertex has to be the opposite of this coordinate, so it's negative 2 for the x. And then whatever is added on is the y coordinate, and again, there's nothing added here, so our y coordinate is 0. So our vertex is at negative 2, 0. So there's our dot. And then since our absolute value is positive, and there's no number in front of this, then we know our slope is positive 1. We can make the dotted lines to talk about that, just like this. So we've got some dotted lines, and we have to decide whether we're going to connect these with a dotted or a solid line. And when we look at it, we can see that we've got the less than symbol, so we know we've got to use a dotted line because there's no or equals to. So we make this dotted line, and it says y is less than, so we're going to shade below the line. So shading below this line means we're going to shade this whole area because all of our solutions are in that area. And that's really all we're doing today. We'll do a couple more examples. We've got y is greater than or equal to negative absolute value of x minus 3. Since this is a minus, we're going to go over to a positive 3 on the x-axis and still a 0 for our vertex. Negative slope means we're going to go downward with our line from that V shape with a slope of negative 1 in both directions. And then we're going to make a solid line because this is an or equals to. So solid line here. And it says y is greater than or equal to, so we're going to shade above this line. So we're going to shade all of this area up here. All right. And then last example of this kind, y is less than or equal to 2 absolute value of x minus 2 plus 3. That means our vertex is at positive 2, but still positive 3. We're only changing the x coordinate, not the y coordinate. And our slope is 2. Pay attention to this. This is something that many of you were struggling with on the last worksheet. If our slope is positive 2, that means from this dot we go up 2 and over 1, up 2 over 1. All right? Some of us were talking about these slopes and not counting the fact that they had a different slope from 1, or maybe saying that that slope was 1/2. But no, that slope is a 2. And then we've got a greater than or equal to, so we're going to use a solid line. And greater than, or sorry, not greater than, less than or equal to means that we're going to shade underneath. All right, so you can shade above or below depending on what the equation tells you to do. So in this case, we've got less than, so everything underneath of this V-shaped line is going to be part of the solution set. Down here, we're going to graph one variable absolute value inequalities because it's something that you may not remember, but you did learn this in Algebra 1. So in this one, we've got the absolute value of x is greater than 2. So in order to do this problem, you have to remember what the absolute value really means. Since we don't have a y equals, we're not going to use a V shape. We're not going to be able to find the vertex here. We just have to think, okay, the absolute value of x is greater than 2. That means that the distance from the x-axis here is going to be more than 2, okay? The numbers on the x-axis, because we're talking about x's, have to be more than 2 away from 0, which means starting here, all of the numbers to the right are greater than 2 away from 0. It's a greater than and not a greater than or equal to. I'm going to make a dotted line. We know that x equals lines go straight up and down, so x is greater than lines will also be vertical lines. But this is also absolute value. And we know that absolute value could also count as negative. We did this in Algebra 1, where if you saw an absolute value inequality, you would split it in two. And one of them would be the same. It would be x is greater than 2. That's kind of what we showed here. We can also shade this because all of these numbers are greater than 2. And we can say that the other variation on this is that x is less than negative 2. So we flip the inequality and we make it negative. You might remember doing that. And the reason for that is because all of the numbers that are less than negative 2 on the x-axis, all of these numbers are also having an absolute value that's bigger than 2 because this number is more than 2 away from 0. This number is more than 2 away from 0. So any number below negative 2 is also going to be included in the solution set of this absolute value of this inequality. All right, another idea here, we're going to use y's. That's a clue to us that our lines are going to go horizontally instead because a y equals line goes horizontal. And this one's a three-part inequality. It says negative 2 is less than y is less than or equal to 3. So we think about that in actually two separate parts. We can read this left part backwards. We can say this is y is, hi Mac, can you move? Thank you. We can say that this means, no, that didn't work very well. Hold on one second. We can say that this means that y is greater than negative 2 because we're reading it backwards here. So if we read this symbol backwards, it says y is greater than negative 2. And I'm going to do that. I'm going to show that with a dotted line because it said greater than. And I'm also going to put in this other line. Y is less than or equal to 3. So if I go to 3 on the y-axis, I'm going to make a solid line there. And we think about all of the numbers that are greater than negative 2 and less than or equal to negative 3 to figure out how to shade this. And those are all the numbers in between these two lines, right? Any number that is greater than negative 2 and also less than 3 is going to be in between those two lines, meaning that is the solution set to the equation. And that's all there is to it, folks. That's all you have to do today on your worksheet. So go ahead and work on that, and hopefully you can get that all finished with relatively no problems. See you later.